These are examples for section 11.2, circle equations and radians. Example 1. What is the degree measure of an angle that is 3 pi over 4 radians? Recall from the notes that there's two ways to measure angles, two different measurement systems. There are degrees, which you're probably used to, and radians, which we just introduced. Many times we have to convert from degrees to radians or radians to degrees. So in this problem, that's what we're doing. In this particular one, we're going from degrees, from radians to degrees. When we go from radians to degrees, we use the conversion factor as a ratio of 180 degrees to pi radians. And so if we're going the other direction, and we're trying to find the radians from degrees, we do it in just the reciprocal way. We have pi radians to 180 degrees and use that as a conversion factor. So we'll be multiplying. So in part A, we have 3 pi over 4 radians, which is really the same as 3 pi radians over 4, same thing. We multiply it by the conversion factor, 180 degrees over pi radians. First of all, look at any symbols or the pi, irrational numbers, anything like that that will divide or cancel out. Notice that pi will divide out and radians will also divide out because they're both in one in numerator, one in a denominator. So we're left with 3 times 180 degrees. 3 times 180 degrees, notice the degrees are still there, over 4 times 1 is just 4. Taking care of the numerical part of the problem, notice that 180 and 4 are both divisible by 4. 4 goes into 4 once, 4 goes into 180 45 times. So now we're left with 3 times 45 degrees, still have degrees, over 1. And so that gives us 3 times 45 degrees, which is 135 degrees. Therefore, 3 pi over 4 radians in degrees is equal to 135 degrees. Part B. What is the radian measure of an angle that is 27 degrees? Take 27 degrees. Since we're using a conversion factor and we're going to multiply with a ratio, we need this to be a fraction. You can always put any number, any whole number, or any other number over 1 to create a fraction. We multiply it with the conversion factor, pi radians, 1 pi radian over 180 degrees. Again, we look for symbols that will divide out because of numerator-denominator combinations, and notice that the degree symbols will both divide out. So we end up with 27 pi radians over 1 times 180 is 180. Notice the degrees went away and we have radians. That's what we want. Then notice that 27 over 180 will both divisible by 9. 9 goes into 27 3 times, and 9 goes into 180 20 times. So now we're left with 3 times pi times radians, 3 pi radians over 20. And this is the same as 3 pi over 20 radians. So 27 degrees is the same as 3 pi over 20 radians, moving from degrees to radians. Example 2. Use the circle at the right. What is the measure of the indicated central angle theta in radians? We have a circle, and we have a central angle right here, theta, and it intercepts this arc right here. And they tell us how long the arc is. Its length is 5 pi inches from here to here. Recall that the angle measure is the same as theta, but the angle measure and the angle length are two different things. The angle measure is the curvature of the arc, and then the length is just the straight line distance from here to here. So keep that in mind. So this would be the arc length. This is theta, the central angle or the measure of the arc, and this is the radius. There's a relationship between all three of these, as we discussed in our notes. And the relationship is that the radian measure here is the same as a ratio of the arc length that the angle intercepts to the radius of that particular circle. This is all based on the definition of a radian. So again, the radian measure, theta, is always equal to the arc length, s, to the radius, r. So when you're given a problem like this where you're asked to either find the central angle, the arc length, or even the radius, you need to be given two of the three of these particular variables. In this particular problem, we're looking for theta. So theta, we don't know yet. Of course, theta will be in radians. And then s is the arc length. In this particular case, it's 5 pi inches. And finally, the radius of the circle is 15 inches. So to find the measure of this arc, central angle right here, we have theta equals s, which is 5 pi inches, to or over r, which is 15 inches. The inches divide out, and we're left with 5 pi over 15 for theta. Remember, this is in radians. And then 5 pi over 15 reduces and simplifies by 5. 5 goes into 5 once, 5 goes into 15 3 times. And so theta is pi over 3 radians, the measure of this angle. We could, if we wanted to, from this point and take pi third radians and change it to degrees if we needed to. And there's one example of how that works. Example 3. What if this time we're looking for the arc length itself? And they give us the measure of the central angle and the radius. We still use the same formula. This one says, study the circle below. What is the length of the indicated arc S? This one right here, from here to here, rounded to the nearest tenth. Okay, so this looks like this one's going to be in inches because the only thing that are in radians are angles, and so arc length is not an angle, it's an actual length. So this would also be in inches, and so would B over here if we were using it. And then these are radians because they're angles. So anyway, we use the same formula as we did in example 2. Theta equals S, the arc length, to the radius of the circle R. Theta, let's define our variables. Theta, in this case, for S, would be the central angle here, 5 pi over 6 radians. And then S, we don't know, that's what we're looking for. And R, the radius of this circle, is 3 inches. Using the formula, we have theta, which is 5 pi over 6, equals S, which we're looking for, over R, which is 3 inches. And this one happened to produce a proportion. One ratio equals another ratio, so we can cross multiply or use cross products. Remember, we're solving for S, so 6 times S is 6S, and 5 pi times 3 is 15 pi. Then, to get S by itself, divide both sides by 6, and S is equal to 15 pi over 6. Now, it just so happens they want us to round this to the nearest tenth, so obviously we're approximating the length of S. The exact length of S is 15 pi over 6 inches. Remember, just because it has a pi in it doesn't necessarily mean it's a radians measure, but most all radians measures have pi in them, but this happens to be a length. So anyway, they want an approximation. So take your calculator. At this point, it doesn't matter if you're in radians or degrees. It just doesn't matter because until we use sine, cosine, and tangent, we don't have to worry about that. Okay, so 5, in your calculator, you can put in 15 second function, 15 second function pi, which is right here, and then divided by 6. And we get 7.853981 and so forth, and we're rounding to the 10th, so let me go ahead and get that down. 7.85398, and so this is about 7.9 inches. S's length is about almost 8 inches from here to here. Example 4. Using the circle below, find the exact and the approximate radius of the circle, R. So we want to find the radius of the circle. We're given a length of an arc. This one right here is 5 meters. And of course we have to use the central angle that intercepts that arc, so we have to use this one. If they'd given us a measure here, we wouldn't use it. We have to use this one. And it's 7 pi over 3 radians right here. So once again we use the same formula. Theta equals S over R. That's arc length over the radius. And let's define our variables. Theta is 7 pi over 3 radians. S is 5 meters, and R, that's what we're looking for, of course it'll be in meters. Theta, using the formula, is 7 pi over 3 equals S, which is in this case 5 meters, over R, which is what we're looking for. Again, we have to cross multiply. So we have 7 pi times R, which is 7 pi R, equals 3 times 5 is 15. Now remember, we're solving for R, or radius. We need to divide both sides by 7, and we also need to divide both sides by pi. Since they're both multiplied together, or all multiplied together, we can go ahead and divide by both those factors, 7 and pi, 7 times pi. So divide both sides by 7 pi. And the pi's divide out, and the 7's divide out, and R is 15 over 7 pi inches. That's your exact answer. But then we also want the approximation. We're going to round to the nearest tenth like we did on the last one. In your calculator, put in 15, divide by 7, and then second function pi, enter. Get about 6.731984258 and so forth. So to the nearest tenth, that would be 6.7 meters. About 6.7 meters is the radius of this circle. Now turning our attention to equations of circles, example 5. What is the equation of a circle in standard form with its center at 5, -2 and radius r of 7? Okay, so recall from your notes when we talked about the standard form of an equation, it's x minus h quantity squared plus y minus k quantity squared equals radius squared, or r squared. So any equation in this form represents a circle on the coordinate graphing system. Now, although they don't have a graph for this, it doesn't matter. We've got the information we need to write the equation of the circle. Imagine a circle on the coordinate system where at 5, -2, which of course would be in the fourth quadrant, you go to the right and down a little bit. So the fourth quadrant would have its center, and then the circle in that fourth quadrant would have a radius of 7 units. Nevertheless, we substitute each value that we have. Remember, the center of any circle on the coordinate system is at HK, H being the x coordinate for the center and K being the y coordinate for the center. So this is H and this is K. So let's go ahead and clearly define these. H is 5, K is -2. And R, the radius, the last one we need, is of course 7. So we take this equation and very carefully substitute in. we have x minus h, which is 5, squared, plus y minus, and now k is negative 2, minus negative 2 squared, equals r, which is 7 squared. At this point, we start simplifying as much as we possibly can. Now, we're not going to multiply these binomials together. We'll just leave them in this form right here. So now this is x minus positive 5, which is x minus 5, quantity squared, plus this is y minus negative 2, which is y plus 2, quantity squared, equals 7 squared is 49. So this is the equation of the circle centered at this place and has a radius of 7. This is the equation in standard form for that circle. Example 6. What is the equation of a circle in standard form with its center at -1, 3 and passes through the point 2, 2? This time they've given us a graph of what they described here. The center of the circle is at 1, -3. And they don't tell us the radius directly. All they tell us is they give us one point somewhere on the circle. It happens to be at 2, 2. And so our task first is to use the standard form, we're going to need not only h and k, which we have, but we're also going to need the radius, which we don't have. So we're going to have to find the radius by right here. And to do that, we need to find, of course, the radius is this length right here, which is the same as distance. And the distance between 2 points on the coordinate system, it has its own formula. So the distance, we're going to call it r for radius, is the square root of, and recall that the formula says that it's x2 minus x1 here and y2 minus y1 here. And so I'm going to let 2, 2 be my first point, and I'm going to let the center be my second point, x2, y2. So using the formula, I have x2, which is 1, minus x1, which is 2, squared, plus, and then over here I have y2, which is -3, minus y1, which is 2. So figuring out the radius's length, we simplify this expression. 1 minus 2 is -1 squared, plus -3 minus 2 is -5 squared. So r, or the radius, is equal to -1 squared is +1, plus -5 squared is +25, and we get the square root of 26 for our radius. And as I mentioned before, h is -1 and k is 3. So we have h, k, and r. Using the standard form of the equation of a circle, which is x minus h, quantity squared, plus y minus k, quantity squared, equals r squared, we start substituting in values, and we have x minus h, which is -1, quantity squared, plus y minus +3, quantity squared, equal r, which is the square root of 26 squared. Simplifying further, we have x minus negative is +1, quantity squared, plus y minus +3, y minus 3 squared, and the square root of 26 squared is simply 26. So this is the equation in standard form of this circle. Example 7. Graph the circle represented by the equation x minus 7 quantity squared plus y plus 2 quantity squared equals 64. This equation is already in standard form for a circle, so we have to identify h, k, and r. It says they want us to use a compass, which is probably the best way to do this if you don't have a compass, or if I think it's important that you know how to do it without a compass also. So I'm going to do this one without a compass. It's a little easier doing it with. State the center and the radius r. So we're going to identify those and graph it and then state those particular points. So to start off with, let's start with the center. And taking a look at our equation here, I'm going to go ahead and take this part right here, x minus 7. And one of the things you got to be careful with when you're looking for h and k, this will be h by the way, is that it's always the opposite sign, because the formula is x minus h quantity squared and y minus k quantity squared. So anytime there's a minus symbol in a formula, it always changes the sign of the number that replaces that particular variable. So for instance, in x minus 7, this would be x minus positive 7. So in this one it's pretty straightforward that it's going to be 7, not negative 7 but 7, and that's our value for h. And then for k, y plus 2, that would be y, the formula is minus, and to get a positive 2 we need a negative 2. Negative times negative is positive. So in other words, this would be negative 2 for k. It's just always the opposite signs from these right here. So the center then would be at 7, negative 2. So I'm going to plot 7, negative 2, start at the origin, 1, 2, 3, 4, 5, 6, 7, down to 1, 2. The center of the circle, we'll label it 7, negative 2. It just so happens, I happen to know that this graph is a little bit too small, and so we'll have to overextend our graph just a little bit when we graph our circle. Next, this is another part where students can get confused if they're not careful. But when you are looking for r, this is not r, this is r squared. So always start with r squared. R squared is whatever's here, which is 64. So to find r, we have to take the square root. So r is really 8. The radius of this circle is 8. And the reason why I say that is because sometimes you get a radius that isn't a perfect square like this. I'll show you one before I finish this problem. Anyway, the radius is 8. So what you can do without a compass is you can start at the origin, or the center of the circle. Don't start at the origin, start at the center. And if you don't have a compass, or one's not available, then what you can do is you can go, you can rise upward, downward, and then to the left and right that number of units. So I'm going to go up 8, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go to the left 8, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go to the right 8, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go down 8, 1, 2, 3, 4, 5, 6, 7, 8. Looks like we had enough room. Okay, and this isn't a very easy thing to do, but what you have to do is you have to draw a circle that goes through all 4 of these points. The temptation is to go from dot to dot, which is not going to make a circle, so you have to be real careful to make it nice and round, all the way around like this. And I'm not going to do probably the best job either, just do your very best. And so there's a graph of a circle. This equation is x minus 7 squared plus y plus 2 squared equals 64. Now, let me show you what I was talking about, the radius. If this had been, instead of a 64, let's say this were a 90 or something. Well, the radius, that's the radius squared. That would be r squared is 90. And so you would have to take the square root, and r would not be 90, and you would have to simplify this. So that would be the square root of 9 times 10. So that's r is the square root of 3 times the square root of 10. So your radius would be 3 root 10. And then, of course, for graphing purposes, you would just take the square root of 90, take your calculator, put in square root of 90, and that's about almost 9.5. So what you'd have to do is you'd have to count off 9.5 units. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. And so your circle would end up going in between these grid units. 1, 2, 3, 4, 5, 6, 7, 8, 9.5, and so forth. This would be about like this. Example 8. Write this circle's graphed equation in standard form. Take a look at the graph. Notice where the center of the circle is. There's your center. So H and K it's pretty easy to find. Start at the origin, you go to the right one, and you don't go anywhere up or down. So the center of the circle is at 1, 0. So that means H is 1 and K is 0. So center at 1, 0. Remember, that's HK. And then, similar to what we just did in example 7, you can figure out the radius of the circle, and you can choose to either go up, down, right, or left. I'm going to go up and count units. We have 1, 2, 3, 4, 5. So the radius here is 5 units. So I have my radius, which is 5. So I've got everything I need, and I use x minus h quantity squared plus y minus k quantity squared equals r squared. Substituting in these three values, we have x minus 1 quantity squared plus y minus 0 quantity squared equals, let's see, 5 squared. So the only thing we need to do now is simplify this. So we have x minus 1 quantity squared plus y minus 0 is just simply y, but it's still squared, equals 5 squared is 25. So this is the equation in standard form of the circle represented by this graph. Example 9. Write the equation of the circle given by the equation in standard form x minus 5 quantity squared plus y plus 2 quantity squared equals 81. In general form is the following. X squared plus y squared plus cx plus dy plus e equals 0. We discussed this briefly in our notes. So we take the circle in standard form, x minus 5 quantity squared plus y plus 2 quantity squared equals 81. The first thing we do is we expand these two expressions since they're both squared. So we have x minus 5 times x minus 5 plus y plus 2 times y plus 2 equals 81. Remember, in general form, everything has to be set equal to 0. So we're going to bring this e over here as soon as we can. At this point, though, I'm going to multiply the binomials together here and here using FOIL or FOIL, just a form of the distributive property. And so we have outside term, or first terms first, x times x is x squared. Outside terms, that's minus 5x. Inside terms, that's minus 5x. And last terms, minus 5 times minus 5 is plus 25. Plus, using FOIL here on these two, we have first terms y squared, outside terms plus 2y, inside terms plus 2y, multiply last terms, so we get plus 4. And I'm going to go ahead and bring over this 81 by subtracting 81 on both sides, and I get minus 81 equals 0. At this point, I'm going to combine these two terms and these two terms because they're both common terms. So we have x squared minus 10x plus 25 plus y squared plus 4y plus 4 minus 81 equals 0. Right at this point, I start putting it in this form. So I'm going to put my x squared term first, x squared. I'm going to go to my y squared term next, which is plus y squared, so plus y squared. Then I go to my x term, cx, which is minus 10x. There's no other x's, so it's minus 10x. Then I go to my y term, dy, so that's plus 4y. Now I have left plus 25 plus 4, which is plus 29 minus 81, would be minus 52 equals 0. So this is the equation of the circle, this circle right here, in general form. And sometimes you're asked to find the values of the coefficients C, D, and E. C would be negative 10, D would be 4, and E would be negative 52.